So this question is pretty straightforward if you can see through it. If you can see that e to the t squared is equal to e to the 2t, and understand that you're essentially looking at a parabola. Okay, that's it. Then this will be easy. But the standard way to eliminate parabolas is solve for t, or one of the standard ways is you could solve each of these equations for t and then set them equal to each other. That would be the long way to do it. And then in this case, you'd have natural log of x plus 1, and then you'd have natural log of e to the t, so you'd get t. On the other side, you'd get natural log of y is 2t, and then natural log of e. So natural log of y over 2 would be t, and then you'd end up with natural log of x plus 1 is natural log of y. This is not the wise way to do this. Maybe put the 2 on the other side like that, and then actually it would be a lot more convenient if we just brought the 2 inside like so, and then we'd say, aha, well now we can drop the natural log on both sides, and then we would say, wow, this was just a parabola all along. It's just this parabola. But we didn't have to do that. We could have just solved, both, could have solved both sides for e to the t, or we could have simply said x plus 1 and then said, aha, if we have e to the t over here, we can square both sides, and then this guy will already match with that guy. And so we could shortcut the whole thing. Okay? So one way or another, you end up with this equation. Maybe you don't end up with a rectangle. Whatever. Yeah, okay. Anyway, this thing. Now, we want to sketch it, and we know there's just a vertex down here. We have this parabola. There we go. Okay. But the problem is we don't really have the whole parabola, and that would cause me to have to take points off your paper, which I don't want to do. So I said, aha, but if I tell them label at least 3 points with their coordinates as well as their t values, then that will convince them that they should think about this. So there's t and x and y. And so then let's see, okay, if t is 0, which I expect that most people will try t being 0. That would be a logical thing to try. I'm not having luck. Ah! I'm not having luck here. There we go. I'm sorry. Okay. There we go. Right, so x is e to the 0, which is 1, minus 1. So 1 minus 1 is 0. E to the 0 is 1. So this would be t equals 0, and it's the point 0, 1. Okay? And then what about t equals 1? Well, most people would try that. It's going to be x is e minus 1. And the other one's going to be e squared. Now, for the purposes of ballpark estimation, e could just be 3. So you're talking about like 2, 9. So it's going to be way up here somewhere. Okay, so t is equal to 1, and then you're going to get e minus 1, e squared. But you think, well, now what about natural log of 2, for example? I don't know. Natural log of 2 is going to be, if t is natural log of 2, then we put it in here, and this turns into a 2. So 2 minus 1 is 1. And if we put natural log of 2 in here, so if e to the 2t, then what happens is it becomes e 2 times natural log of 2, then that becomes e natural log of 2 squared, which is e to the natural log of 4, which is just going to be 4. Okay? So somewhere in here, you're going to get t is equal to natural log of 2, and then you're going to get 1 comma 4. And then you're like, okay, well, at least I'm getting some normal points. I may have to put in a natural log, but I'll get some normal points, and maybe I'm done. But hopefully you went this far and you just felt a little uneasy because you didn't try anything negative. So let's just try negative infinity. Because if we know we're going up here, the thing is, it doesn't seem very symmetric, does it? You would expect t to be down at 0 if you're going to get all the points on this parabola, because you'd expect 1/2 of the parabola to be the positive t's, and the other half of the parabola to be the negative t's. But you should be getting a little suspicious because you're really close to the vertex at t equals 0, and then you're shooting off. So it's like, how do you get down to the vertex? Okay, so let's just see where negative infinity goes. Well, e to the minus infinity is 1 over e to the infinity, so that's 0. 0 minus 1, rather. And then the other one is just going to be 0, and you're going to say, whoops, that is t equals negative infinity. And so this curve is going to go up. You got a parabola going upwards, but it has an actual starting point. Because you limit down to this point. You can never ever reach that point, but that's where you're limiting to. So it's not really true to say t equals negative infinity, but what we mean is limit as t goes to minus infinity of the curve, the points on the curve, is equal to minus 1, 0. That's what we really mean. But for shortcut, I just say t equals minus infinity, and I hope you know what I mean, because I'll assume I know what you mean. Clean some of this stuff up. Anyway, hope that helps.